So many of us are visual learners, so in today's lesson we're going to use visual models to help us better understand fractions and mixed numbers.
Here I have two rectangles. I know they're not exactly the same size, but they're pretty close together, and we're going to use that to just model for this part. And I want to ask you, what fraction does each one represent? And I'm going to fill this part in here. Whoops. And I'm going to fill this one in here. So just imagine they roughly fill in this whole little part. Definitely not perfect math marbles, but I keep trying anyway. We are all human and we all try our best, and that's the most important thing. So starting off with the first part, if this whole rectangle represents 1, you'll notice I definitely broke it up to 2 pieces. And I've shaded in 1 piece out of 2. I had to laugh at my drawings too sometimes. And in the second one, my one rectangle is broken up into 4 pieces, and I've shaded in 2. So my question is, do they represent the same value, and how do we know? Well, if we assume that one whole rectangle is, if they're the same size, in one I cut it into half, and the other one I cut 2/4, but they're pretty much the same thing. They're 1/2. I still have half of this rectangle shaded in, and this one is half a rectangle, even though they're different pieces. So we can safely say that these two fractions are equivalent to each other. I love this word equivalent, meaning they have the same value as one another. And I'm going to rewrite this as 1/2 is equivalent to 2/4. Hey, pause for a second. You try your own drawings and be as graceful with yourselves as I am with my drawings if they're not exactly perfect, but represent 1/2 and 2/4, and jot down that they are equivalent. Awesome. So let's look at one more, and we're going to look at equivalency again. And we're going to try and think, are these 3 fractions equivalent? 1/2, 2/4, 3/6. So let's try drawing 3 rectangles again. Pretty, not exactly close, but we're trying. But I'm going to show how one we're going to cut into halves. The other we're going to cut into 4 pieces. And the other into 6 pieces. And now I'm just going to shade in, so we kind of had this section, use my highlighter. So here's 1/2, 1 out of 2 pieces, 2/4, and 3/6. And you can notice that all of them are, again, roughly the same. We're both covering the same amount of each one. I'm still cutting them in halves, and so all 3 have an equal value. And my question to you, math marbles, is to look at these numbers. Do you notice anything? What do you see? What do you notice? Do you see any relationships between the 2? Well, one thing I see is I notice there's a little bit of a relationship happening between these 2 numbers. I've noticed that it's the 2's. If I wanted to get to 4's, it's almost like I multiplied by 2. And the same thing with the top numbers, like I multiplied by 2. Do you see that? That there's a relationship here, that the second one is just as if I multiply my numerator and my denominator by 2. I also see that relationship with 3 and 6. Do you see the multiplication, the fact family relationship here? Think about your fact families. And if I multiply by 3, I would have the same number. I would get the same value. Math marbles, when we're thinking about equivalent fractions, to think about your fact families. There is a multiplication factor happening here with these numbers. And I'll show you what I mean by using a table. Another drawing, because I know how much you love my drawings. I'm going to put my original number 1/2. since that was the simplest fraction we had, the simplest one. And imagine I'm going to just use my ratio table to skip count to make equivalent fractions. So count by ones, 1, 2, 3, 4. So in other words, this is times 2, times 3, and times 4. And I'm going to do the same thing with my denominators, 2, 4, 6, and 8. So again, times 2, times 3, and times 4. And what I have here are 4 equivalent fractions. 1/2 is equivalent to 2/4, is equivalent to 3/6, is equivalent to 4/8. I can use a ratio table to help me demonstrate and even find equivalent fractions. Hit pause so you can jot this down into your notes. This is another way we can draw models to show equivalency, but like I did, sometimes our models aren't always exact and we may not draw them to scale. But a ratio table can also help us model and demonstrate equivalent fractions. And we know they're equivalent because we're using a multiplicative relationship. We are using our multiplication to create equivalent fractions. Now you have 2 different strategies for making equivalent fractions. We're going to explore this a lot more throughout the year, Math Marbles. We will see you in the next lesson.